Okay, we're going to be looking at the piecewise functions, and this time you're given the picture and you're given the graph of the function, and you have to write the equation that represents that graph. So let's go ahead and get started. I'm going to look at this piece first and then this piece second, and it doesn't really matter which order you look at them, but I'm going to call this f of x, and there are two pieces. And so as I look at those two pieces, I'm going to think about my domain as well, because okay, so if I imagine this being a line and it continuing all the way down, you can see our y-intercept would be at 1, 2, 3, at -3. And our slope is a -1. So our equation would be f of x equals -x minus 3. And we're only looking at those values, everything less than -4. So x is less than -4. -4 is an open circle, so it is not included. Okay. As I look at this piece is going through at 2, 4, at 6. So it is f of x equals 6, and the values that we're looking at are at -4, and everything going this way forever. So x is greater than -4, but it's also equal to, because it has a solid circle there. Alright, our domain and our range. If we look at our domain, our graph goes forever in this direction, and it goes forever in this direction, and the -4 is included, so this is going to be all real numbers. And for our range, the lowest it goes is right here at 1, and then it goes up forever. So low is 1, high is positive infinity. And 1 is not included because it's an open circle. Okay, so pretty easy on that one. Let's look at number 2. Number 2, we have two pieces again. So I'm going to call this one g of x. You can call it whatever you want, but we're going to list it in function notation. So if I look at this piece, again, it's going on. There's a little arrow there. This is a solid at 2, 4, 6. So it's going to be g of x equals 6 when x is less than 0, because here's 0, it's going this way, and it's also equal to 0 because it's a solid circle. Looking at our parabola, this point right here is 1, 0. That gives us our h and our k. So when I write this as a quadratic, it's going to be x minus, and it's going to be -1. We don't need to put the +0, but we do need the -1. And we're looking at that for values of x being greater than 0. So it starts here and it goes this way. And that's it. Our domain and our range. Our graph goes forever in this direction, and it does go forever in this direction, because as it goes up, it goes to the right. So all real numbers again. And our range, the lowest it goes is down here to 0, and it goes up forever. So 0 to positive infinity. 0 is included. Okay, we have two more examples. So let's look at these next two examples. This one has two pieces. So I'm actually going to write it underneath for this one. Got a lot of space on my paper. F of x is equal to, and I'm going to have two pieces. This first piece is at 2, 4, so it's at 4, so f of x equals 4 when x is everything smaller than 2, so less than 2. Not equal to, because that's an open circle. This here is the absolute value. The vertex here is at 1, 2, 3, 0. So this is our h, this is our k. So the absolute value of x minus 3. We don't need the +0 out here. And now we're going to list the values that we're looking at. 2 and everything greater. And our domain is forever this direction, because it's got that arrow, forever this direction. So this is going to be -infinity to positive infinity. or all real numbers. Our range, if I look at my range, the slowest it goes is down to 0. It's equal to that. And then it goes up, it only goes up to here and then it jumps, but it's okay because here it goes up continuously forever. So, positive infinity. The last one, number 4, we have 3 pieces. If I look at this piece and I imagine that it is a line, there's a lot of different ways you can look at this, but if we think of this as a line and we see that this is down 1 over 2, if we continue that same pattern, you can see that it goes through the y-axis, so our y-intercept would be 0. So down 1 and over 2 would be negative 1/2 x. We don't need to put the plus 0. The values for x that we're looking at are at negative 4 and everything less than, it's a solid, so less than or equal to negative 4. This piece here in the middle, when I look at that piece, it is a line. We can think of it as part of a line. And if it's part of a line, that slope is a positive 1, and it goes to the y-axis. So this would just be f of x equals 1x, or just x. And the values for that x are between 4 and 0. So it's between here and here. So, negative 4 and 0. When you show it between, it looks like that. Now, is it equal in either of these cases? Well, this is an open circle, and this is a solid. So this does not have an equal to, but this one does. And our last piece is this horizontal ray. It is part of the line y equals x, or f of x equals, I said y equals x, I meant y equals 1, or f of x equals 1. And the values that we're looking at are everything from here going this way forever. So x is greater than 0. It is not equal to 0 because it's got an open circle. Alright, domain and our range. So when I look at my domain, it goes forever that way, and then we've got this piece that covers this distance, and then it goes forever that way. So all real numbers. Our range, there's a jump in this graph right here and right here. So if we start at the bottom and work our way up, it looks like we're at negative 4 to 0. So negative 4 to 0. And the negative 4 is not included, but the 0 is. And, or union, this piece, which is at 1. It doesn't have a top or a bottom range, it's just at 1. And then this piece starts at 2, and it goes up forever. So the low end, again, union, the low end is 2, and the high end is positive infinity. 2 is included, and then we do the infinity that way. Now, I wanted to go back and show you that there were other ways that you could have looked at this graph. So let's go back up to this first problem. So for this first problem, what if you didn't see it as a line? What if you said, you know, I want to see this as an absolute value. I want to see it as this, being part of that absolute value. So how else could we have written that first part? Well, another way to write that first part is to see that it is, the vertex is at negative 3. Let me write this over here. This would be, if we did this part, it would be negative 3, 0. So we could, for this first piece, we could have said x minus a negative 3, which would be x plus 3. And then the domain would be the same. X is less than negative 4, because we wouldn't really want this piece right here. We just want that piece. So that's another way to talk about that first piece. We can even do it a different way. We can even say, we don't want to have that be the vertex. We want this to be the vertex. So we could say it looks like this, but then only wanting this part. If that's the case, then that vertex would be at negative 3, 1, which would make our piece of this whole function would be x minus a negative 3 plus 1. And then this would all be the same over here. A little interesting that you can have some choices there. Another one that you can have a choice on is down here at number 4. At number 4, you could, instead of making this a line, you could make it a parabola, or this one. Instead of making it a line, you could make it a parabola, where it goes down like this. I keep saying parabola, but I meant absolute value. So you could make this absolute value for this middle one, for this one right here. We could actually write that, again, just showing there's different options. We could say it is the absolute value of the opposite of the absolute value of x, but only wanting the values that were between negative 4 and 0. So this part will look the same, but this part could be a negative absolute value of x. Different ways you could do it. You could have it go this way. And if that was the case, another option could be saying that the vertex here was at negative 4, negative 4. So if our vertex for this first one was at 0, 0, if our vertex was at negative 4, negative 4, then that would look like this. We would be saying it opens up, so it wouldn't have a negative, but it would be x minus a negative 4 minus 4. Same restrictions for our domain, but just interesting that there's different ways that you can write that. Okay, that is it. I'm going to go ahead and stop, and good luck on the homework.